Hello students, today we'll start the first chapter of class 7. Before starting that, let us remind some well-known numbers. This chapter will start that is known as rational number. Now, before starting a new kind of number, let us discuss what we know already in up to class 6. We know counting number or counting numbers or another kind of number that is known as this is known as natural numbers, counting number or natural numbers. So in this case, the example of these numbers are 1. It starts from 1, 1, 2, 3, 4, 5, 6, and so on. This is the collection of natural numbers. Now, if we include one more number with this, that implies if we add 0, particularly if this 0 number, this number is added to this natural number, all these natural number 1, 2, 3, 4, and so on. This collection is known as whole numbers. Whole numbers. Now, if we take the collection of all natural number 1, 2, 3, 4, and so on, 0, and the negative of all those number -1, -2, -3, -4, and so on. This collection, this is known as all these numbers are known as integers. So these are known as integers. We know natural numbers, whole numbers, and integers, and another kind of number that is fraction. And what is fraction? This is part of a whole. It is part of a whole. It is of this form. A number of this form p by q, where p and q are natural number. That implies starting from 1, 2, 3, 4, all these numbers, natural numbers. When p and q are natural number, then it is known as fraction. Now, so all these numbers we know already, we know up to class 6. So today we will define a new kind of number that is known as a rational number. A rational number. See that it is same as fraction, but here the restriction of p and q are natural numbers. But if the number is of this same form, so what is natural number? Any number which can be written as, or which can be expressed as, p by q, where p comma q both are integers. Listen, see this, integers, and one more restriction is there, that is q not equal to 0. Q is also 0 is also integer, but the p and q both are integers and q is not equal to 0. So in case of fraction, they are natural numbers. P and q are natural numbers, but in this case p and q are integer with q not equal to 0. Then we say that this number p by q is a rational number. Now check that in case of integers, there are positive numbers also, negative numbers also, +1, -1, +2, -2, like that. So this fraction cannot be negative, as this p by q is a natural number. All p and q are natural number in case of fraction. So this fraction cannot be negative. But in this case, in case of rational number, p and q may be negative number. So rational number can be negative. We will define what is known as positive rational number, what is known as negative rational number, all this. Now So we define rational number. I'm repeating it again. A number of the form p by q, where p, q, these are integers, and q not equal to 0. Actually, this is p divided by q, and we know that we cannot divide any number by 0. That's why this q not equal to 0 is condition is there. Now, as positive integer, negative integer, as p and q all can be positive, negative, or both positive, both negative, or p can be 0 also, then we can define positive rational number, and negative rational number, positive rational numbers and negative rational numbers. Now, see, in case of positive rational numbers, see that this p by q, this is general form of a rational number where q not equal to 0. This condition is there. P and q both are integer. This is known as numerator, as in case of fraction. This is known as numerator, and this is known as denominator. Now, when both p and q are of same sign, that implies it actually they will be positive. When both p and q are, so the rational number or a rational number, the rational numbers are said to be positive. When they are said to be positive, if signs of numerator and denominator, both numerator and denominator, both numerator and denominator are same, then we can say that rational number is positive rational number. Actually, they will be positive. See that if we take 3 by suppose 4, in this case both of them are plus. Similarly, if we take -3 by minus suppose 11, in this case we know that we can cancel out this -1. There are some properties of rational number. This is also a positive rational number. Both signs are same, then we say that they are known as positive rational number. So denominator and numerator both are of same sign, then we say that rational number is a positive rational number. Now, when it will be negative rational number, check that. Let me erase this part little bit. There will be negative rational number if the sign of the denominator and numerator are opposite. The rational numbers are said to be negative if the signs of numerator and denominator are not same, or we can say that are opposite. For example, same number if we take 3 by 4. So if we take 3 by -4 or -3 by 4, either this will be positive and the denominator negative, here numerator negative, denominator positive. So these are the example of negative rational numbers. Now, I told already that every fraction can be a rational number. See that fraction imply p by q form, where p and q are natural number, but every rational number cannot be a fraction, because this -3 by suppose 7, this is a rational number. This is a rational number, but it is not a fraction. And why it is not a fraction? See the definition of rational number. any number which can be written as p by q form where they are natural number, then they will be, we know that they are fraction. But in this case of minus 3 by 7, it is a rational number but not fraction, as this minus 3 is not natural. As minus 3 is not natural, so we cannot say that it is a fraction. If only 3 by 7, it is both fraction and both rational. So minus 3 by 7 is, but minus 3 by 7 is not fraction, it is a rational number. Okay, let us discuss some properties of a rational number. As we know some property of all those kind of number, associative property, identity property, like that we know in class 6. In case similarly there are some property for rational number, so we'll discuss those properties here. So first property is when two numbers are said to be equal or equivalent. Suppose p by q one rational number and r by s another rational number. When they are said to be equivalent or equal, listen, here both q not equal to 0 as a rational number and s is also not equal to 0. Now we say that p by q and r by s are equivalent rational numbers if this one p into s is equal to q into r. If p into s is equal to q into r, then we say that they are equivalent rational numbers. Because if we take suppose 4 by 6, it can be written as 2 by 3 also after cancelling 2. Similarly, it can be written as 40 by 60 also. So which number we will write? All of them are equivalent to each other. This kind of number are known as equivalent. If we simplify, we will get this 2 by 3 in both cases. Then this 2 by 3, 4 by 6 and 40 by 60, these are known as equivalent rational number. For example, take another example. Suppose minus 2 by 9 and 4 by 18 minus 18. Suppose, how to check they are equivalent or not? We have to check this minus 2 into 18 and 9 into 4 are equal or not. So minus 2 into minus 18, that is equal to 36, and 9 into 4 is equal to 36. So they are equal, 36 equal to 36. Therefore, we can say that minus 2 by 9 and 4 by minus 18 are equivalent. They are equivalent rational numbers. They are equivalent rational numbers. Second property of this is property 1. This is property number 1 for, so this one is property number 1. And what is the property? To check whether the numbers are equivalent or not. Next, let us check one more example whether they are equivalent or not. Suppose one is 4 by minus 7, another is 8 by minus 13. Check the cross multiplication. 4 into minus 13, that is equal to minus 52, and minus 7 into 8, that is equal to minus 56. So they are not equal, which implies that 4 by minus 7 and 8 by minus 17 are not equivalent. So this is example of not equivalent fraction. Let us proceed to the next property, that is property number 2. Property number 2. 2 and 3 both I will discuss together. 2 and 3. Actually, this property number 2, it is if p by q is a rational number, q rational number imply q not equal to 0. This is natural number. P by q is a rational number. Then we can multiply any non-zero rational number, any non-zero number with both numerator and denominator. This is the second property. We can multiply any non-zero number other than this. M cannot be 0. Then they will be equivalent. That imply, only write this, so you are taking a note, p into p by q is equal to, we can write that is equal to p into m divided by q into, sorry, m, both m, for some number m not equal to 0. Similarly, the property 3, this is property number 2. Property 3 says that we can divide also that this p by q is also equal to, p divided by, suppose k divided by q divided by k, where k is a number, we generally take integer, and k not equal to 0. K is a number, k is not equal to 0. These are the property, second property and third property. So take some example to clarify this property number 2. And this property is, suppose there is 25 by 40. So we can divide one non-zero. Suppose we are dividing this 25 divided by 5 and 40 divided by 5. Then it will become 5 by 8. This 25 by 40 can be written as 5 by 8, like this. This is the property, sorry, this is property number 2, mistakenly. But similarly, we can write 3 by 9 or 3 by, suppose, 19. We can multiply this by some non-zero number, suppose 3 into 2, 19 into 2. This is example of property number 2. So this is equal to 6 by 38. So we can multiply, if in any problem or to solve any problem, if we need to multiply that, we can multiply any non-zero number, or we can divide any non-zero number. Now in previous slide, I was talking about this, that which number we'll write. Okay, now we'll discuss or we'll solve that problem, that what to do if that kind of number is there. So see that we are taking this 4 by 6, 2 by 3, and 4 by 6, 2 by 3, and 40 by 60. So which number will write? So in this case, this number, see that we cannot break this number or simplify this one more. This number, this is simplest form, this is the known as standard form of a rational number. So we'll define that standard form of a rational number. So in case of rational number, check that. In case of rational number, check that there is no common factor between 2 and 4. There is no common factor between 2 and 4. Sorry, 2 and 3. Sorry, 2 and 3. So let us define that p by q, a rational number, p by q is said to be in standard form if there is no common factor of p and q other than 1. That is, we know that concept, GCD of p and q is equal to 1, and another restriction is there. This q is always positive. Q is positive integer. Q is positive integer. integer. Then we said that this is in standard form. So a rational number is said to be in standard form if q is positive. This is another first condition or second condition you can take. GCD of p and q is 1. No common factor other than 1, or HCF or GCD is equal to 1. So take some example of that standard form. Okay, I am taking 4 by 9. This is in standard form. But 4 by 6, this is not in standard form, because we can simplify it to 2 by 3. Now take this 2 by minus 3. This is not in standard form because the denominator is not positive. So this is also not in standard form. But minus 2 by 3, this is in standard form. Minus 2 by 3 is in standard form. So remember that this q is positive. This is very important point for standard form. Okay, so we'll solve two worksheet related whatever